Hi boys and girls, it's me. And I just wanted to stop this before I got the proverbial YouTube police with the copyright infringement stuff going on. But I just wanted to stop this for a minute. And this Zenith AM FM radio that I just finished going through for a friend of mine. And it actually has a phonograph input in the back, so I was actually playing my iPod through it. And I'm cheating. But that's not why we're here. But I wanted to raise some awareness about certain components, especially that Zenith used in these radios. Okay, boys and girls, what we have here is I actually have a paper schematic of an AM/FM Zenith radio. It's not the exact schematic of the radio I just showed you, but it's pretty darn close. And I just wanted to point something out to you. First of all, a lot of these AM/FM Zenith table tube radios were pretty similar in circuitry, little changes here and there. But one thing always remained the same. Okay, what I've got down here in front of you is basically that's the main power of the radio coming in. And then you can see toward the bottom of the picture, you can see the filament string, how it ties in. But there's one thing that's fairly common to these radios, and also the transoceanics. Okay, you can see the main power cord on the left. That little wire up on top there is just a little, that's just the where you would get your FM antenna. It has no real function in the schematic, but if you start looking to the right there, and you see a little picture of the diode there, and showing it as M1, and next to it is a 22 ohm resistor. Well, this particular radio, the schematic anyway, and the one I just worked on is a 7-tube radio, and if that diode wasn't there, it would probably be an 8-tube radio, and it would have some sort of a rectifier tube there, probably like a 35W4 or 117Z3 or some kind of rectifier tube there. But I think in the way that Zenith engineered this thing, they just wanted to use what's called a selenium rectifier, and thus that's why they have the little diode symbol right there. Whoop! I'm going to get yelled at again. Got to use my fancy pointer. There it is, right here. That's the selenium rectifier. But we're still not even talking about that. What I want to talk about is this capacitor right here. That's actually in line. And then you have a 0.047 microfarad capacitor, and you see it's going to the ground. And this is what I want to talk about here. I'm going to show you. Now again, Zenith uses these in both the tube transoceanics and the AM/FM tube radio. So you're actually going to see these in a lot of sets that Zenith put these in. Okay, drum roll. This is it. This is a 0.047 at 600 working volt. Oh, I just got paged. There was my phone. That is a Bumblebee capacitor. And I want to show this to you. I mean, the light isn't too good, so I'm going to show this to you underneath my illuminated magnifier. I want to show you little things about this capacitor. As most of your radio repair folk already know, that these things are, capacitors usually have to be changed anyway. They become leaky, they develop resistance, their values usually increase. The couplers do anyway. I think the electrolytics do as well. If you look at this guy real carefully, if you look toward the left-hand side, left of the yellow stripe, there's actually a crack there. You see that crack? And that ain't all. This might be a little hard to see, but if you look at those two round circles there, and then you go down the length of the capacitor right over the stripes, there's actually a crack running down horizontally as well as vertically on this capacitor as well. So given that knowledge, knowing that this was a 0.047 capacitor, wonder what it's really reading. Okay, boys and girls, I've got the capacitor connected to my tester. Okay, I got little clip leads, one on each side. Alright, let's turn it on and see what the value actually is. Okay, I don't know how well you can read that. It says 113.3 NF. So it's actually 0.1133 microfarad. So this value of this cap is basically more than doubled, and then showing a voltage loss of 6.3%. That's your leakage. So not very good. So what does all that mean? Well, let me try to put it into some sort of perspective. You know how it's like, your mother, your father just kind of start in on you, and they want you to take Fido out for a walk, and it's raining and nobody really wants to go outside except for Fido. So you go out with Fido and you bring your scooper, you bring your bag, and you take Fido out, and Fido does his thing, and you clean up after him, and then you come back to the house with the bag, and now you and Fido are totally soaked, but Fido has since been relieved, and now you've got this bag. Well, you know what? You can add this to it. These things, I've actually saw one of these one time in Transoceanic. I was actually bringing it up on a Variac, and as I was bringing it up, I think I probably had it up to about 75, 80 volts, and I actually heard the radio start to play on the broadcast band, but then this guy it literally popped. It wasn't like a loud thing like a firecracker. It just went pop, and then a perfectly symmetrical ring of smoke bellowed from this thing. It was like watching a cartoon, and I just threw myself back in the chair. I started to laugh. So if you see any of these guys in your radio, I think it would probably be a good idea to take these out, as well as the wax caps or any other capacitors you find in the radios that are no good. So I know that the audio folks love these things, but in my opinion, they're landfill. So anyway, hey, thanks for watching, and take care. Bye.
What's with all the crap?
It's not crap.
It's Crapacitors.